All right, at this point, right, we have a surface that's subdivided. You should all be aware now that when you look at the U and V value, it's giving you a numerical input. So it's as easy as dropping a slider on to change what that value is. So I'm going to say 0 is less than 50, I guess I'll start with, to 100. So see how that jumped up to a whole bunch more subdivisions? I did 0 to 50 to 100. Come on, guys, it's Powerball time. We're using bigger numbers. To 100. 292 million. 1.5 billion. So, I'll show you again. 0 less than 50 less than 100. Enter. That's what I made. So we're actually not going to use the 50 now. We're going to do something a little bit more tame. So you can pull those back down to like 10-ish. So at 8 and 11, you can see that now it's fully parametric, very similar to our grid. The difference here being that the grid is not measured by the extents of the surface, right? So you can't necessarily map a grid, given its parameters, onto a surface. You have to subdivide that surface, and that's where that tool comes from. So the other thing that I wanted to show you here is the different type of domain reference that you can do, right? So we took an existing surface and we cut it into equal parts in two different directions. However, another thing we can do is actually change that referential surface very easily. And it works like this. So the divide or construct domain squared is going to take your reference surface, reconstruct it based on a proportional numerical relationship. So when it says lower limit of domain, that's saying, this is one maximum value, the maximum at the lower level, or minimum, I should say. And then there's an upper limit for U. And then there's the lower limit for V and an upper limit for V. So knowing that that is one number and it references one surface, what do you think it's going to do? It's going to modify one surface using 4 numbers. And I said that it's a proportional modification. So what do you think it's going to do to a singular surface?
Divide it evenly over those numbers?
Nope. It's going to alter the width and length, right? But it's going to alter it based on what the existing minimum and maximum values are. So this is what this one looks like. I'm going to copy these. Let's see, what do I want? That's going to give us a new domain. I think we can ISO trim that. Let's try that. So copy the surface and the ISO trim down, and then you can disconnect the domain. And if you really want to see what's going on, hide the existing information. So, did I lose you? Did I lose anyone? Okay. So anyway, so we have this new domain that we're going to modify, and we have a lower limit of 0 and upper limit of 1. And so I'm going to plug that into the D of the subdivide surface. Oh, that didn't give it to me. What do I need? What do I need? I think I need to recreate. I think I'm using the wrong surface creation. Hold on. Oh, I remember. Sorry. So there's something different about this, using this kind of domain. You have to do something that's called reparametrizing. I know it sounds like a mouthful, but really all that means is that I'm changing the game about what the reference is going to be here. So I believe the reparametrize has to go on the input of the surface, if I'm not mistaken. I might have to trial a few things here, but it's this one right here. And so if I click on reparametrize, there you go. Now we have a reference surface that actually calculated. So the best way that I think I can describe that is that it's saying, rather than simply looking at this surface as an object, we're going to look at it as a mathematical boundary, I think is kind of the best way I know how to describe it. Definition-wise, I couldn't give you an exact definition. But anyway, what you see here is when you select that, you get one solid surface. But take a look at the correlation of the numbers, right? We have the lower limit is 0, the upper limit is 1. And I said it's proportional. So I can drop in a slider that says 0 is less than, and in this case, I'm going to do 0.55. So 0.5 means that it's going to automatically set my number slider to not give me integers, but it'll give me real numbers. And then I can say up to 1.0. All right. What's that? 0.55 to 1. And actually, there's going to be an error in this. I'll show you in a bit. But make 4 copies of this. And then just start plugging them all in. And notice how it's changing. And it gave me an error.
You can't change that information by right-clicking on the input and then set, as we did before with other nodes.
You can. Yeah, you can. I'm doing it.
To switch between integers.
Yes. Well, not to switch between integers. So, guys, the question was, can you right-click on the input to change the value? You can change the value. I could, if I right-click on that and go to set number, I could change that to any number I want. It'll be a static number. If I type in 1, it'll count as an integer. If I type in 1 or 0.55, then it'll be a real number, 0.55. It's whatever I type in. So I did this just because I'm, showing you the flexibility of it, right? Rather than doing static numbers. So, did that answer your question?
Yes.
Okay. All right. So, yes.
I'm lost completely.
Completely lost.
I'm completely lost.
Okay. So, then don't worry.
Going, actually. I don't know why we're doing this thing.
I'll show you. We're going to get there. But you got to know how to do this first. Trust me. Just trust me.
Like you're telling me, okay, I'm going cook cookies with this. The end is cookies. Now let's go do it together.
Yeah.
I'm lost.
But you can't jump to the end with this.
I don't want to jump on it. I want to know what is the end.
Oh, so that's a good question. I tried to explain it a little bit without giving too much away. Maybe I need to give you guys more teasers. But
One thing.
so, well, should I explain what we're doing first? So what we're doing is, you have all this massing around the site. And I mentioned a little bit as we got started about articulating that massing, right? The real powerful thing about Grasshopper is that you have the ability to articulate all of that massing all at once. So rather than just, going through and actually, how we did with the cube assignment in the class that you were in, actually creating geometry, copying it or arraying it, and then doing a subtract command to punch a hole, and then doing the same thing to model other things in, it can all be parametric. So once we model one subdivision with one subtraction across one surface, all we have to do is select all the surfaces across the entire site, and it'll do it for us. Everywhere. Rather than having to do it manually yourself. That's what we're getting at. So it feels very abstract right now because we're not actually working on the surface, but I'll show you how easy it is to move from an abstract exploration directly onto the surface afterwards.
So
Don't worry about the specific numbers yet. Just worry about what we're doing.
I want to explain to kind of like understand. That surface is connected. Something is going to be cut it, and because we're going to cut it, we need the dimensions, and that device is going to be that measurement and dimensions, right?
Sort of.
Okay.
For all intents purposes, yes. That's why we're doing this, because we're going to map these moves onto all of the surfaces of the massing models.
Okay, I have another question.
Yes.
What is that reparametrize?
Reparametrize?
Yes, what is that?
My definition probably didn't do it justice, but basically it means I'm going to change the way I'm looking at the surface that you've given me. And I'm saying, me as the subsurface command. Reparametrize basically is telling me, right? Like you feed me a surface and you say, all right, look at this and cut it up. But when I reparametrize it, it's saying, well, rather than just cutting it up as a physical geometry, I want you to look at it as a boundary, as a set of data, rather than just, a surface that can be modified. Does that make sense?
I don't know.
Well, just take a look at what it does, and then you'll understand, I think. So anyway, to try and wrap things up about this, when we plugged in using construct domain squared, right? When we plug in the values, right, we have these decimal values, 0.45 or 0.55, whatever you made, it gives us an error. The reason it's giving us an error is because our lower limit and our upper limit is coincident. Coincident meaning they exist in exactly the same place. So as I move the U value lower limit down, you'll see, actually I need to move another one down first. So there. So as I move them down, you see that it's actually creating a geometry across the surface based on the proportional limits that I'm setting. Does that make sense? So if I pull my upper limits to 1 and my lower limits to 0, then I have a full surface. As I pull them in, it becomes less of a full surface.
So is it two surface or just one surface?
That's a good question. Perhaps I should refresh on that as well. So, like I said in your intro last week, and it has been a while, so I get it if you don't recall this, but technically it is two separate surfaces. It did not create two separate surfaces. It has a reference surface. It created a new surface. So in Grasshopper, unlike Rhino where you chop something and delete it and it goes away and it's gone, in Grasshopper everything is always there. You just turn it off. That way you can go back and you can reference data again later on. So this surface goes away and I turn the preview off, and now I can modify this without the original surface. Okay, so going to move on here in a minute, but what questions do you have?
Well, I have one. So any changes you make within this new surface, they're not going to go outside of that boundary. Like, for example, if you map or you put, like how we did last week, where we put all the circles, we made it in a grid-like form within that surface. It won't go outside the boundaries of those lines.
That's a good question. I actually don't know if it can go beyond. I imagine if it had to go beyond, I would have to move it up to like a value of 2, and then maybe it could go beyond. No, it looks like it won't let me go beyond because it's constructed a maximum proportional relationship of the original surface.
What about objects that you put on that new surface that you created?
So
Let's say you want to make little panels or little subtractions of some sort so that they won't go into the original surface.
that's a very good question. So his question was, what if you put new geometry on it? will it stay within its own boundary or will it go beyond the boundary? That is actually the benefit of using this versus scale, because you can scale to anything, above or below a value of 1 or 100%. So if I did scale on this surface instead, it could go beyond the boundary. But because it's a boundary limit, a domain limit, then it can't go beyond. Now, if you mapped a secondary geometry onto it like a circle, depending on where you place the circle and how big you make it, of course it could go beyond. Unless you limit it referentially, mathematically. So do you know what I mean by that?
Yes.
Okay.
I don't know how to do that.
Yeah. But conceptually you understand that it can be done, so. All right, so any other questions? Yeah.
Quick one. Are you in shaded or wireframe?
In Rhino? Wireframe. Okay, so I'm going to stop this video here, and then we'll move on to some other stuff here in a few minutes.